Here's a problem that's going to allow us to practice using the reaction quotient to solve for concentration or to solve for the direction of this reaction. So as the reaction is written right here, you can see that over time it's going to go and form product, and then at some point all this product will accumulate and it will go backward and form more reactants, and at some point you're going to get an equilibrium established. Well, at equilibrium it tells you right there that the K value is 170, and they give you quantities. Here's a molar quantity of the reactant, and they tell you the volume. Here's the molar quantity of the product, and of course it's going to be in the same volume. So the first thing I'm going to need to do, because it's asking me, is the system at equilibrium, I'm going to have to solve for Q. And you know, you write a reaction quotient the same way you do an equilibrium expression. We just call it Q because we don't know if it's at equilibrium or not. So that's going to be N2 O4 divided by NO2 squared. Now I'm going to put values in for this and see if that ratio is going to reduce to 2. It may, and if it does, if I get exactly 2, I'm sorry, not 2, 170, I'm thinking of another problem. If when I put my values into this expression, if I get 170, I know it's at equilibrium. If I don't, then we have to decide which way it's going to go. So the first thing I need to do is solve for the concentration of both of these so I can divide. I got a molar quantity of the product, so that's 1.5. So let me just go down here and we'll solve for the concentration of N2O4. And that is 1.5 times 10 to the negative 3 moles in 10 liters. And when I do that math, I'm going to get 1.5 times 10 to the negative 4 molar. I'm going to do the same thing for my reactant concentration, which is NO2. And that's going to be 2.0 times 10 to the negative 3 moles. In the same volume, they're reacting together in the same container, so use the same volume, 10 liters. And when I divide that out, I get 2.0 times 10 to the negative 4 molar. Now all I have to do is take these quantities and put them into my expression. So on the top, I'm going to say 1.5 times 10 to the negative 4. And on the bottom, I will say parentheses 2.0 times 10 to the negative 4, and that's squared. And remember, the units really don't matter in these quotient values. They don't have a unit. So when I plug that into my calculator, I'm going to get a really large number. And yeah, it's 3,750 for a value of Q. So in this example, you can see that Q is much larger than K. And when Q is much larger than K, that means that this reaction is reactant favored, and the concentration of NO2, which is your reactant, is going to increase quite a bit. It's reactant favored, so that means the reverse reaction is going to occur and increase your amount of NO2. And that's how you use Q to figure out if a system is at equilibrium and which way it will proceed.